Hi, good morning all of you. I hope you all are safe and prepared well for your exam. Okay, today we all discuss about the new chapter, that is NMR spectroscopy. Here the NMR spectroscopy trends that the letter N means nuclear, M tends to magnetic field, and R for resonance. Okay, and the word nuclear comes from nucleus. Okay, as we all know that nucleus contain proton and neutron. Okay, the nucleus contain both proton and neutron, the proton having positive charge and the neutron having neutral charge, and the spin quantum number for proton is plus half and the neutron is also plus half. Okay, if a proton is said to be NMR active, then the proton should have some charge and non-zero spin quantum number. Okay, it means the proton is a NMR active. Okay, then here the word magnetic field means when the proton or the neutron, as we all know that the nucleus contain proton and neutron, when the proton revolve along the axis or around the axis, it create a magnetic field. Okay, here is the structure of nucleus, and proton and neutrons are present in the nucleus, and proton is revolve around like this. Proton revolve around the axis, then it creates some magnetic field. Okay, and when the proton absorbs some amount of radio frequency or some kinds of frequency, and if this frequency is similar to the nuclear radiation, then this phenomenon is known as resonance. Okay, is this clear? If the proton absorbs some kind of frequency and the frequency is similar to the nuclear radiation, this phenomenon is known as resonance, and the whole study is known as spectroscopy. Means the study of this whole spectrum or this technique is measured by spectroscopy. Okay, and hence it is known as NMR spectroscopy. In short, the NMR is a spectroscopy technique which is based on the absorption of electromagnetic radiation in the radio frequency of region, that is 4 to 900 megahertz. Okay, in the radio frequency region from 4 to 900 megahertz by the nuclei of the atoms. Okay, that means the nuclei that absorb some radio frequency which is lies in between 4 to 900 megahertz, and the study of this technique is known as NMR spectroscopy. And here hydrogen having one atomic number and one atomic mass is known as PMR, or hydrogen, as you know as hydrogen is a proton, and the study of hydrogen is known as PMR, or proton magnetic field resonance spectroscopy. Okay, so hydrogen is one of the most powerful tools for the elucidating the number of hydrogen or proton present in the compound. Okay, so let's move on the topic, that is where the compound, that is NMR active, or the compound NMR inactive. Okay, there is some kinds of rule or some kinds of some points that we have to follow that to identify the atoms or the molecules that is NMR active or NMR inactive. The number one point is you all seen here, that is non-zero spin quantum number. If the spin quantum number, which is denoted as I, if the spin quantum number is not equals to 0, then it is known as NMR active. If the spin quantum number is equals to 0, then it is known as NMR inactive. Okay, here is the first point. Then atomic mass, atomic number, okay, atomic mass and atomic number. If the atomic mass is a odd number and atomic number is also a odd number like H11, then it is known as NMR active. Okay, like this, if the atomic mass is odd and the atomic number is even, then also it is known as NMR active. For example, 13C6, C613. Okay, and also if the atomic mass is even and atomic number is odd, then it is also known as NMR active. For example, N714. And if the atomic mass and atomic number both are even, then it is known as NMR inactive. For example, oxygen 816, carbon 612. Okay. So, how can we calculate the spin quantum number? That means the value of I. Okay, there is an easy process to calculate the spin quantum number. As we decided that the nucleus contains proton and neutron, that is I is equals to P plus N. Okay, the spin quantum number of proton plus the spin quantum number of neutron. Okay, then we calculate the value of I. Okay, let's see that we calculate the value of I for H12. Okay, if we calculate the value of deuterium, then here we know there is 1 proton plus 1 neutron. For the spin quantum number for 1 proton is half. For the spin quantum number of 1 neutron is half. Half plus half is equals to 1. So the value of I is equals to 1. So if we calculate the another value, that is C612. Okay, C612. Then as we all know, the carbon 612 has 6 proton plus 6 neutron, and 6 neutron means they are paired with each other and cancel out. So that's why the value is 0. Okay. So here, if the atomic mass is odd and atomic number is also odd, then the spin quantum number, that is I, is equals to half or 3 by 2 or 5 by 2. If also the atomic mass is odd and atomic number is even, the value for the spin quantum number is also half, 3 by 2 and 5 by 2. But if the atomic mass is even, atomic number is odd, then the spin quantum number is 1, 2. Thank you, and that's it for the today's class. Next class we will discuss about the principle of NMR active and other topics.